Hello, protocols, packets, and programs. Horror movies have a trope of abandoned locations that includes a reveal about the dreadful testing that occurred there to make them so haunted. Places like abandoned hospitals, orphanages, or even underground bunkers, but also places closer to us, places like abandoned code repos. Which means this week we chat with Jason Recla about AI, cybersecurity, and bringing the worlds of development and data science together. In the news segment, Fortinet flaw in a forwarded header, memory flaw in a Linux kernel Wi-Fi, a bad mode in Office 365 message encryption, security communities, secure code courses, and more. Strap yourself in and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys CloudView, the next generation cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. CloudView enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, improve compliance and audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. Securing the modern enterprise requires insights into massive amounts of data. NVIDIA Morpheus harnesses the power of AI and GPU computing to help protect networks in a way never before possible, enabling 100% data visibility to provide cybersecurity analysts the tools to identify, capture, and act on threats and anomalies. Sign up for a free 1-hour NVIDIA Deep Learning Institute course. To learn more, visit securityweekly.com/NVIDIA. This is episode 216, recorded October 17th, 2022. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Sorry, you confused me with the date. Go. I'm like, wait, hang on a second. Oh my god. Hey, it's good to see you. I'm gonna try and sit on my hands for the next half hour and not jazz hands about machine learning.
We'll jazz hands about 216, October 17th. I can't even remember what I just said too. So this is an excellent start. And for those of you who don't want to miss any excellent starts like we just demonstrated, visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server, and follow us on social media and our streaming platforms. Jason Recla is a senior director at NVIDIA, responsible for the global information security program, from policies and awareness to compliance, security operations, and incident response. He's a cybersecurity leader with more than 20 years of practitioner experience that ranges from managed security services and offensive security consulting and auditing to security strategy, architecture, and enterprise cybersecurity planning and program development. Hello, Jason. Thank you for joining us.
Hey, Mike. Thanks for having me.
So it's, reading through your background, you've done maybe, I was going to say a little of everything, but I think over 20 years, you've probably done a lot of everything. And as we get started here about, AI and cybersecurity, I'd also kind of just curious about some of the basics about you're working with, I think, developers more so now. What brought you to where you are now to be focused on working with developers, working on protecting organizations?
What brought me to be where I am now? I don't know. It's been a solid 15 years now with NVIDIA and helping build that organization, the security organization here. So I think over time, like you said, kind of touched a little bit of everything as we've built up the function. But getting to work closer with developers, I guess, in a couple of ways. One, we started kind of on the SDLC many years ago now and continue to kind of improve and build around that in terms of what we're doing. But beyond that, also partnering very closely with a couple of engineering and development teams as we, go on this journey of leveraging AI and ML for cyber. And I think that's the most exciting thing over the past 5+ years is kind of working with those teams that have helped build up what was initially NVIDIA Rapids, and now Morpheus, and then partnering with multiple teams to apply that kit, that software development kit, and use it in house.
Yeah, and I want to kind of want to take some steps into that AI and aspect of things, an ML aspect. But also, you're talking about working with several teams. Normally, we on the show talk about AppSec and DevOps just as easy shorthand. But here, especially if we're talking about ML, you're bringing a data science team into the mix here. So I'm kind of curious, what's it like to bring a data science team and an engineering team together?
It's a good question. So we have, like I said, multiple teams working this together. The data science team has been great to work with, right? When I first met them here at NVIDIA, they were thirsty for data, and I had years of data that we've been hoarding, if you would. And so it was a perfect match, right? And then working together directly with the data science team to kind of step through what are some of the challenges, with in working with that data. I mean, cybersecurity is a data problem, I think, and so working with them to kind of go through different scenarios and challenges was great. But bringing together the data science team, the security operations function, and this sort of engineering team has been interesting. It's been a lot of learnings, right? Like we need to bring up the engineering team to kind of establish and operate the technology, and then the core data science team that's developing kind of the Morpheus product is in the mix as well. So I think part of the challenge there is just coordinating across those three different teams to all march in the same direction towards the same outcome. But it's been a lot of fun. I think that there's all sorts of challenges in the middle of this, right? But part of it is just trying to get the right architecture. There's a lot of people involved. And trying to kind of iron it out and work through different iterations has been part of the challenge.
Yeah, and you touched on there about one of the challenges among many is you do have a lot of data now, and I'm going to guess just to sort of illustrate a point is that the data could come from just access patterns, could come from just net flows, could come from lots of other things, and I think part of if I recall from introducing you, part of your background or what you're working on right now is a SOC. And there's a lot of data that can kind of come through there. So you're working with data science, working with an engineering team. Are you building just a faster grep, or what's the problem here? Help us understand the problem here of having something better than grep against all these massive amounts of data.
Sure, I think that it is much more than just a better grep, right? Splunk was a better grep for us, but putting that aside, I think part of what we're using AI and ML for is identifying those patterns, right, or anomalies. This is something we've strove for in the industry, I feel like, for quite some time, to get kind of high fidelity output from anomaly detection, right? There's all sorts of anomalies, but the really cool part comes into play, I think, when we're looking across multiple data sets sort of simultaneously, right? Identity attacks being kind of one of the newest areas, not new in that it's been around for some time, but new in that it's in the news all the time these days. And it's tough, right? What's anomalous for a given user out of 20,000 or 25,000 employees, and then across different time series, right? What's normal on Tuesday might be not normal on a Saturday, but doing that across multiple identity sources, right? Most companies, many like NVIDIA, have multiple identity services, Azure, on-premise AD, logins to different applications, and so forth. And so trying to pull all of that data together, right? Whether that's for your shop, whether that's terabytes or petabytes, or it just continues to grow. I think looking across that huge data set is the challenge in trying to correlate across all of that, right? We've had correlation rules that are more static by nature that you can do against individual streams, maybe across a couple, but orchestrating that across dozens or hundreds of log streams and event streams. And that's, I think, just scratching the surface, honestly, right? There's still petabytes a day that you could be collecting or inspecting in real time at the edge of telemetry from endpoints individual applications, CDN logs. There's a ton of untapped monitoring, I guess, potential for evil, so to speak, in all of that data that we're just not able to do today.
Yeah, and a lot of that, you went through a nice list of very disparate sources that I'm also going to guess have very different types of structure to them. These log files are not always like a timestamp in microseconds and then an IP address and then something else. So we haven't, before we even get into that aspect of anomalies, how much of this is, as you mentioned, maybe tell us a bit more about how that is a data problem itself. And here I'm also thinking, part of the reason I'm asking this is, mentioning petabytes of data. If you have accuracy issues of in 1%, 1% of petabyte is still a lot of noise that some, SOC engineer would have to sift through.
Yeah, I think a couple parts to that question, but one of the kind of upfront bits was I remember talking with our Morpheus and prior Rapids team a few years ago about one of the challenges for the SOC, and that is just onboarding these different data sets to your SIM or to your log analysis platform. To your point, different formats, parsing each of these logs, building regex to parse the appropriate fields out, and then every time a vendor updates or a developer updates the way that they log, things break. So one of those early wins, I think, was Cybert and Clicks, and that was a model that can learn how to parse a given log source via ML. So it makes it a little bit easier to bring in at higher rates and adapt to changes in the log formats. If you don't have to have a human in the loop to build your regex for your different log sources, right? Different fields also present a challenge, right? Some logs may clearly identify that it's Mike Shima that's logging in. Other logs may only have an IP address that's not necessarily associated to Mike. So I think that's another challenge in the data set as we try to grow.
That's a great point too. And I think one of the things we were also just talking about right now is, still on that aspect of just trying to collect all of the data or aggregate it, is you were mentioning a lot, I think at the network layer, maybe at the edge, or about identity. But what about the application layer? Is this an area where you struggle to get good signals from? Is this an area that you need to have more of those discussions with the developers building it so they can actually generate logs? Or are there frameworks that are helpful for generate the types of signals that would be useful for you to collect and then analyze?
I think in the past, at least in my experience, analysis of kind of the application layer logs when it gets outside of the core collaboration suites and identity suites wasn't necessarily a focus for a lot of SOC capabilities, right? In part because what's there to see, right? If it's an authenticated user interacting with your defect tracking system or the next application, particularly for corporate intranet, right? It may not produce a lot of signal for the security team. But as we go forward, with the deperimeterization and everything's on the interwebs, watching what a given user's interaction with an application looks like and identifying any anomalies in their behavior with interacting with that application, applying that to insider threat type use cases, what's different today than yesterday, is becoming, I think, more and more interesting and necessary. So collecting all of those logs. In terms of what logs to collect, I think there's a pretty good baseline out there already, and just kind of the fundamentals that app developers are using. What was the resource that was accessed by who and when, and the 5 tuples, if you would, source and port and destination, and all of that fun seems to be sufficient at the moment.
I'm curious, do you guys find it on that scale, and with the multiple dev teams you have for multiple applications, do you find it easier to get that type of data from a commercial product than an internal team?
I think commercial product log sources have the benefit of easier integration for a lot of the common tool sets, right? Whether we're talking about our SOAR kits or the the SIM integration that out of the box is a lot more straightforward than internal or in-house. But the platforms for the different applications on the presentation or web layer at least are pretty common. There's only so many web servers, app servers that are out there. So it's not a huge challenge. I think part of, like I mentioned earlier, with Morpheus and Clicks, being able to bring in these different log sources and parse them without having to go through extensive human learning is helpful, though.
Whereas coming from that is, I imagine in an organization of that size that there's a pretty good amount of cat herding that has to happen inside to get all the different teams to do that, versus a commercial product has already had to deal with the cat herding from a bunch of different customers. So, but
that's
still
fair.
Interesting to hear.
Yeah, that's fair. And I think the collection of the logs is the next challenge, right? If there's only so many firewalls and VPNs and Active Directories in an office, but when the better part of 25,000 employees are developers and engineers of some form, standing up different services, microservices, and platforms across the globe and across multiple cloud platforms, just knowing that they exist in the first place, and then working with each of them to collect the logs into a central place, or apply your monitoring capability via inferencing at the edge, is a coverage problem, right? And I think that is probably one of those undiscussed or not often discussed challenges for a lot of security teams is true coverage.
Yeah, isn't that one of those classic, a security checklist? Do you have an asset inventory? Yes, no, and which is easy to ask, easy to say, but good luck trying to implement that. Talking about maybe like the idea of coverage or collecting all of these signals, gathering these logs. So you now have petabytes perhaps of data, or actually you do have petabytes of data for what you've been telling us. How then do you also avoid the toil of dealing with so many signals? So, a worry, and I'm not sure how well-grounded this would be that we have more data, we have more logs, so now we're just getting more signals about this might be anomalous, or this is sketchy, or and now we do need a human to go look at this. And I think this is part of the pitch of what ML is there. But maybe tell us a little bit about that, or characterize how ML is helping those humans in the SOC deal with the things they want to deal with, or they should be dealing with.
Yeah, it's a great question. More tools, more detection does equal more alerts in general. So there's always tuning, right? We always have to go back and try to tune and fine tune, and do that as an ongoing iterative thing through processes in our SOC, like alerting and response, and detection engineering, hunting, and so forth. I think part of the promise with ML and Morpheus on our side is trying to surface the things that are most significant and bring them to the top. It doesn't mean there aren't other issues to go be dealt with, but what are those most significant issues that you don't want to miss right now, because they're going to likely become a bigger incident, if you would, if you don't deal with them sooner than later. Identity is a great example, right? Identity-based attacks is a great example of that, in that it may not be a super noisy event that someone logged in, because someone logs in all the time. But if it's the wrong person logging in, if you don't get on top of that quickly, it could become a really bad day, right? Identity breaches or incidents can result in data loss, access to your environment, as many of us have seen this year, that just can go really sideways. So I think part of what Morpheus is doing for us is highlighting those important events sooner than we might have caught them before. Down the road at some point, I think many of us are already working with SOAR tools, right? And still today we're manually implementing those SOAR, those response playbooks, and to automate responses. And I think we're getting a lot more aggressive with the automated response, but potentially down the road we can leverage more of kind of the AI and ML promise towards even the response actions and moving quicker. Another area that we're exploring a bit, so this isn't new, but this notion of risk-based analytics, right? And whether you're talking about the Microsoft platform or other SIM tools that are out there, assigning weighting and risk scores to a given user or a given asset based off of all the different anomalies, then you're focusing more on the identities or the assets that have accumulated the most risk over some either long or short period of time, as what you're going to go after first, right? The days of whack-a-mole with malware are not gone, right? But there are other signals that I think are more important, and there's some great content. Bartley, who's resident genius in my opinion here, helping build the Morpheus platform, presented at GTC some great visual tools that we're introducing to our teams for seeing kind of those most significant risk areas or identities within the environment in near real time, and kind of highlighting and playing those back. So pretty cool developments.
That's interesting because I love that risk-based aspect and being able to essentially decorate, label the areas of where you're more interested in, because that's where that's where the risk is, to use the truism. I'm curious there, how does that also relate to building the models to be able to identify these anomalies? Because on one hand, I'm going to perhaps guess that if you have a nicely secured network, there may be anomalies, but that could be someone logging in on traveling, some of those cliche types of exceptions that this isn't risky behavior, versus here is someone who's demonstrating how Uber had a bad day with a compromised credential, getting into Slack, being noisy. That's maybe one of the easier models to build up, but a lot of what ML relies on, I think, are these models to say this is anomalous. So how do you approach training that or building those models up so they're not just focusing on the next Uber being really noisy in the Slack type of breach, or only the breaches that we've seen in the past?
That's a good question. I think you're right that if you've got a specific data set, right, and we've done this internally, where there was a significant or noisy breach, and you train just against that, you run the risk of, when you go back and apply that model, saying, well, it's either showing a lot of things, but it's not identifying real issues. So I think at the moment, the way that we're dealing with that is just, there's many different types of models that we can apply, right? But our next kind of area is simulations of those sort of events in production, right? So how do we go back and once we've got the model that we believe is trained, it's generating some amount of alerts or anomaly scores, how do we get our own red team, our OffSec team, to go in and do an op or something that ideally would trigger similar detections? So that's one approach to it. Another is, there are events on a regular basis that are happening, right? They may not be as significant as what we've seen in the news lately, but still kind of precursors. And the earlier you can get to detection in that kill chain, the better. So we see those somewhat regularly. How do we verify that the models themselves are triggering on those kind of precursor events? So I think that's pretty important.
Sorry, going a little bit further with the red team concept. Looking through the Morpheus website, getting a sense, looks like something fun to play with. Have you or the team, or just in general, thought about, as you get to know a tool like this and you get to tune and customize and all things you've been talking about with it and get the experience with it, has there ever thought about actually sharing those fingerprints, I'll say, back out with a wider community? I know we're sort of on the edge of AppSec here, but just curious if that's...
Yeah, absolutely. So I guess there's two parts to that. First I want to mention, Morpheus is really that developer toolkit, right? It is meant to be shaped and used in how you and your organization want to use it for your use cases. But one of the most exhilarating things I've done over the past 5 years is, like I described earlier, partnering with that team at NVIDIA for our use cases, and them building up these different models, right, that we share out publicly. And whether that's the DFP model that we've been iterating on since earlier this year for digital fingerprinting, or prior models around things like DGA detection and a stream of DNS queries, or a number of others. And so those things that we build up and put back out there in the public are meant to be examples of what can be done with it, but also that you can take and directly apply to your environment and tune to your needs. Did that answer your question, John?
Yeah, no, it did. It's and I know we've covered some of those, but I guess um, I'm possibly thinking a next step further of. So you've got like the model of, like you said, mentioned the digital fingerprinting. Would the fingerprints themselves be worth sending back out there, or the reason I brought this up is it's a little tricky, right? Because once you figure out the pattern, you don't just want to like publish it, but at the same time, it could help others. That's the. Does that make sense?
That's fair. I mean, when I'm thinking fingerprint, it's the model of what an individual employee's activity looks like over a given period of time, right?
Uh-huh.
So I don't know that that's helpful in sharing, but I think there are insights that potentially we could learn along the way, that maybe make their way back out there in the form of blog posts or otherwise that accompany some of this content that we put out there in terms of the models. It Or maybe there's generic models as well. I think I'm starting to get into an area where it'd be good to go back and talk to some of my data science friends, to kind of see what could be exposed there. I know, for example, that within the environment, there are some identities, maybe they're lab accounts or service accounts, where there's not enough activity to necessarily generate a user-specific model. And then there's, of course, lots of humans here, who are very active, and then we have like a per employee model, if you would, that's being built up in the back end as part of the DFP deployment. So I don't know. It'd be interesting. The fingerprints themselves, to your point, I'd have to go back and talk to the team and see what's possible there.
Neat.
Yeah, along that theme, talking at the microcosm aspect of sharing, I'm curious what has been the communication or feedback cycle between the SOC, the end users actually consuming, using Morpheus, the signals, and the data science team or the engineering team putting this together. Because I'm wondering, were there surprising feedback or just lessons? And this is, actually, we shouldn't be just security folks building tools for security people. We are actually building it for humans and developers. And there's user experience types of considerations that you might not have predicted at the beginning.
Yeah, it's been an adventure, I suppose. Earlier on, I think there was a lot of, come check out this cool graph. Like, isn't this going to help you guys spot the anomalies and the evil and hiding amongst everything else? And early on, the sense was like, that's not helping us, right? I think that there was some transactional nature to the SOC where we said, like, give us an alert that we can go action. Don't give us a fancy graph that we can't interpret. So we've iterated a lot over time. The latest visualizations are helpful, but in the middle there, what's the back and forth look like? Certainly there's been quite a few points where we were seeing just a wall of anomaly scores without categorization per se, right? Is this good or bad? I don't know. It's an 11. On what scale? It's not really set. And I think that was a challenge, and I think early on, the SOC team didn't fully grok what was happening behind the curtain, right? Like, how does this ML work, or is it just producing a bunch of anomaly scores? So I think over the past year, gone through some iterations of trying to establish certain thresholds of, if it's above this score, then it's bad. It's a high, medium, low, just to get back into what people are used to. Explainability has been a significant ask as well from the SOC back to the engineering and development teams to say, I want to understand why the model believes this particular user at this particular time is anomalous or bad. Because at the end of the day, the models right now aren't predicting to say something is obviously evil or that there's a compromise. They're just saying that there's a higher level of anomaly associated with this user at this moment in time than the other users. So I think that explainability has been huge as well, because for a while there, the SOC analyst just kind of got a report. Here's 5 users you should go look at, without any reasoning as to why, or understanding of what are the features of the model or the features that are being extracted from the logs or derived from the logs that are therefore driving that anomaly score up. Other than that, I think there was some need for kind of a closed loop process between the SOC and the analysts, and the developers just to do reviews, right? Okay, if these are the top 5 you want me to go look at, fine, but I need to have some closed loop to send that feedback. Like, we looked at it, and here's why we think there's nothing wrong or nothing risky going on with this user's account. Maybe it was just they changed phones, and therefore the browser string changed. Maybe it was they decided to turn on some new security feature of their fancy phone, and it used a VPN to anonymize their source, and that therefore it looked like impossible travel. So the SOC team is sometimes having to go in, investigate, and say, I see this is why, I think this is why. But the explainability piece where the model is telling them why the model thinks it's interesting has helped in terms of that closed loop process between the SOC and the developers.
Yeah, that's a wonderful example of just clearly demonstrating this is the value we're delivering, or the better value we can deliver through an example of explainability. Are there other areas that made the SOC kind of perk up and say, oh, this is helpful, or this is value? And here I'm thinking either specifically with Morpheus and the work you've been doing here, or even if there's a broader lesson of just, building security tools for end users rather than just for the sake of having tools with pretty charts on them?
That's a good question. I think that the SOC is inundated, right? Like even prior to ML, AI, and we hear this a lot, right? Alert fatigue, and so forth. So I think one of the most interesting bits is that ability to raise the focus for specific areas of concern, right? Amongst all of that noise, if you would, or all of that signal, what are the things we should go after? And historically, if you're focused more on, okay, this type of event is parsed into our SIM as a critical. Well, I've got to take care of the criticals, and I've got to take care of the highs, and maybe I don't have time for the mediums or the lows or the informationals. But leveraging Morpheus to, for us, kind of pull out hey, this cluster of events associated to this user, you may not have already got to the top of your queue, but here's why we think it should. That's been very helpful.
And then I'm curious too, is a lot of this is the unfortunate aspect of these type of anomaly detection where it's reactive, right? We're looking to see, had someone compromised a credential? Have we been breached? Given all of these signals and the experience you've had, the time that you've put into this, are there certain areas that you walk into an organization, or you could point to an area and say, well, you don't have a good asset inventory, so we already know you're going to have problem X, or this is what your phishing stance looks like, so you may have problem Y. Are there some proactive just guidance recommendations that you come up with, lessons that people can learn from before they even dive into perhaps overwhelming the SOC with all of the signals from the bad stuff going on?
I mean, I think we say it a lot, but ML aside, right? Getting the fundamentals right, and as you suggested, is super important, right? And some of those are things like single sign-on, so you have a consistent login plane, right? Whatever your platform of choice might look like. MFA, everywhere, right? Including internal is huge. To your point, knowing and coverage, we talked a little bit about coverage earlier, but knowing your coverage and working towards making sure you've got the appropriate coverage is big. Identity being such a huge thing right now. There's not enough to be said around, making sure you're getting ahead of your adversaries and knowing about what users in your environment have some sort of identity exposure of one shape or form. So I think that's also quite huge. I don't know. There's a lot, but the fundamentals and getting the fundamentals right is super important.
So then, looking ahead now, you mentioned that the presentation, the GTC conference. I think we have a link to that presentation on the show notes, so that's interesting. I'm curious, is there something else that you would love for listeners to be either thinking about, looking forward to over the next couple months, or some particular call to action, whether it's as simple as turn on that MFA or ingest another log file, or something a bit broader than that, perhaps?
It's a great question. I think cyber is and applying AI and ML to cyber is a great next frontier for us. I'm personally looking forward to how we expand the use of AI and ML at the edge via inferencing. So we don't have to collect all of those terabytes and petabytes of data to a central place, right? I think that what's interesting in concept and hopefully in practice here soon is taking what you learn centrally via a subset of data and being able to apply it kind of globally at the edge to a broader set of data, so that we don't always have to collect all of the logs, right? Not everybody needs to have a $5 or $10 million a year, cloud, log storage budget, right? If you can apply these models closer to the edge, there's a huge benefit to that, right? It's for all of us. So that is kind of where I'm looking at going. So I think it's most interesting.
That is interesting. Maybe that's something that we glossed over a bit too much, because there's talking about budget. You're going to get any CISO's ears to perk up, right? And there's a I'm going to guess a big correlation between budget and security, or budget and risk. And to kind of repeat what you said, there's a shift here to say, rather than just invest in storage, so rather than in space, we're going to do it, call it time, or call it just processing. And that's I think what you mean by the edge. We just want to shift our detections to CPU rather than disk space, to if that's not overly reductive.
Or GPU, if I could, right?
Or yes, good point.
Yeah, absolutely.
No, that's wonderful. So I think I'm out of questions there. John, anything else that we should make sure that we put Jason under the gun for here while we've got his attention?
I was just thinking about that last one there, actually. I really like the idea of, to use the phrase, moving this type of detection to the edge. But are there other lessons we can go back to the developers with? And what I'm asking is, so you're crunching this ton of data, you're figuring out patterns of what we're seeing from malicious and good users. Is there a higher level pattern which sort of comes out that the SOC guys see that, hey, we'd love to see either more of this? We think, in other words, are you seeing at a human level that they could put some of this detection into code, into the application internally?
So it's a thought, right? That's the concept, at least, whether we put it into the application or we put it into some sidecar to the application that runs on these servers or services. But I like where your thought is going there, John, right? Like ultimately, if you could give the application developer the ability to deploy this model and somehow as part of their application, the application could almost become self-aware to do some sort of alerting back to a SOC team to say, hey, I just saw something very anomalous with this user because I have a per user model and it tells me that this user's behavior normally looks like X, but today I saw Y, and that was off the charts anomaly score, so I'm going to generate an alert. That could be another just event in the application log stream, or it could be something out of band that could trigger back to the app developer, could trigger back to a SOC team to take a look at it. So I think that's a great idea.
I'll wait for my royalties.
Well, thank you for good ideas, John, and thank you, Jason, for joining us and telling us about cybersecurity AI and just that data science and developers working together in general.
Yeah, thank you, Mike. I appreciate it, John. Mike, nice meeting you both, and have a great rest of your day.
I want to thank all of our listeners, and if you'd like to learn more about NVIDIA, visit securityweekly.com/NVIDIA. We're going to take a quick break now and return with news of the week.